Today's problem from statics, and this is from virtual work, and the problem is ABCD is a rhombus formed with 4 rods, each of length L. Length of each rod is given by L and the weight is W, joined by smooth hinge, and a weight small w attached to the lowest point C, that is the lowest point of the rhombus is C. Okay, frame raised on 2 smooth pegs in horizontal line, and B and D, here B and D are 2 corners of the rhombus, are joined by a string. Okay, if the distance of the peg apart is 2D, distance of 2 pegs which are in horizontal line is 2D, it is given, and angle at A is 2 alpha, so that the tension in the string is given by this. Okay, now we first draw a rhombus in vertical plane with C as the lowest point. ABCD be the rhombus and C is the lowest point. Here the weight W attached to the lowest point C. Here give a weight of W. Okay, and each length rod AB, BC, CD and DA are L. Both and all the side of the rhombus are same, so all of them are L. We know that AC and BD are 2 diagonals of the rhombus, and the intersection is the center of gravity of the rhombus. Okay, and weight of each rod, that is W 4W, act through the center of gravity of the rhombus. So this is the point of action of 4W, and this is act vertically downwards. Okay, let 2 pegs which are in horizontal position, let one peg is at P and other peg is at Q. Okay, this is Q, and here it is given that PQ is given by equal to 2D. Okay, and if let it be G dash, then P G dash, this is equal to G dash Q, this is equal to D. Right, now since PQ is 2 fixed peg, so the line PQ is fixed line, and we measure all the distance from the PQ vertically downwards. Right, and here 3 forces are act. The first force is weight W through C, so we have to find the length C G dash. This is the first length we have to determine. The second length, here 4W act through G, so we have to determine G dash. This is the depth of G. And third of all, here BD is a string, let the tension is T, and we know that the tension always act inward direction, and tension try to decrease the length of the string. Okay, but string in the system must be increased. Okay, so here tension is the negative force. Okay, so here we have to find the length of the string, this is BD. Okay, and here it is given that this angle, the total angle is 2 alpha, so angle is alpha, here angle is alpha. Right, now since this is L, so from the triangle ABG, we get AG, this is equal to L cos alpha, and it is equal to GC, because AG, this is equal to GC. Right, now here we have to find C G dash means we write this is CG plus G dash. Okay, now we have to find G dash. and we write this is CG plus GG dash. What is GG dash? We know that this is given by L, sorry, this is given by D. It is given that PQ is 2D, so this is given by D and this is also given by D. So from the triangle APG, from the triangle APG, we write this is alpha, this is the height of the triangle, so we write AG dash, this is equal to D cot alpha. Okay, and now we get from here this is CG and G dash can be written as AG minus AG dash. Okay, AG minus AG dash. This is GG dash, and also we know that CG this is equal to AG. We write here, so we get 2 into AG minus AG dash. Okay, by putting the value of AG, we get 2 into L into cos alpha minus AG dash. This means D into cot alpha. We write or we get the value of CG dash. This is the first required value. And the second one is GG dash. GG dash, we already find GG dash. GG dash, this is given by AG minus AG dash, and this is L cos alpha minus D cot alpha, right? And the third required distance, this is BD. BD, what is BD? BD is given by this length, 2 into this length, so 2 into, we write first BG. Okay, BD means 2 into BG. And what is BG? BG means 2 into L sin alpha. We get from the triangle ABG, right? This is G. Now we give a small virtual displacement of the system consisting all the geometrical conditions such that the angle alpha is changed to alpha plus d alpha. That is the small change here. Okay, and we write like, now we give a small virtual displacement such that the angle alpha change to alpha plus d alpha and consisting all the geometrical condition of the body. Okay, and there be a change in all length of the system. So the equation of virtual work can be written as, since the geometrical condition of the system is same, that is the consisting all the geometrical condition, so from the equation of virtual work we get the equation as, here we first the force into the small displacement. The first force is W into small displacement is D of, the length is C G dash. Okay, because the length from G dash to the force W is G dash C, so we write D of G dash C. This is positive force because the force acts vertically downwards and the length of GC must be increased by the force. So this is positive force. And the second force is 4W, which acts through the center of gravity G, and the depth of this force is G dash G. Okay, and this is also positive force. So we get, this is plus 4W into D of G dash or G dash G. And the last force, that is the third force, is the tension of the string. This is T, and we already say here tension force is always negative force. Okay, so this is negative, but D of BD is positive because the length is increased to consisting the system. So this is negative, that is D of BD, and this is must be equal to 0 in the equation of virtual work because no geometrical condition violate. Okay, now we put all the value here, that is W into D of CG dash. We already find here CG dash, which is given by 2L, this is cos alpha minus D cot alpha, plus this is 4w into g dash g. G dash g means L cos alpha minus D cot alpha, and minus T into D of, this is BD, so 2L sin alpha, this is equal to 0. And differentiating, we get W into, this is given by 2L into minus sin alpha plus D into cosec square alpha D alpha. Okay, plus this is 4W into here D here, so this is minus L into sin alpha plus D cosec square alpha D alpha, and minus this is 2LT into cos alpha D alpha, this is equal to 0. Now taking common D alpha from 3 term and cancelling D alpha term, we get the value of T as 2LT sin alpha, sorry, this is not sin alpha, this is cos alpha. Cos alpha we let or write it left side, and in the right side we write D W cosec square alpha minus 2L W sin alpha and minus 4 capital W L sin alpha, this is plus 4D capital W cosec square alpha. Okay, now we get T from here. T is equal to D by 2L into W plus 4W into cosec square alpha by cos alpha, and this is minus 2L and 2L cancel out, this is W plus 2W into tan alpha. Okay, and if we take common tan alpha from both the term, we get the result as T, this is equal to tan alpha into, this is D by 2L into W plus 4W into, this is cosec Q alpha. Okay, this is not cosec square alpha because we take common tan alpha, and the last term is minus W plus 2W. Right, this is our answer, and I think in the problem we write here, there is some small mistake here, this is Q. Okay, and this is the proof, and this is the complete proof of the problem.